All right, friends, we're going to start talking about ellipses today, so a totally different shape than a parabola. So just right up at top, an ellipse is the focus of points such that the sum of the distances from any point on the ellipse to two fixed points remains constant. So that's just kind of that picture you have down below to the right. These fixed points are called the foci. So we talked about a focus before, so foci of the ellipse. So in that picture, that's just saying this any point on the ellipse, so that green point I just highlighted, these distances D1 and D2 would remain consistent no matter where you have a point. So like even if I picked a point right here, the shorter one, that could be like D2 plus D1, that would be the same, okay? So D1 plus D2 remains constant for all points on the ellipse. So here's these next 5 things here are going to be kind of the main things that we're going to talk about with an ellipse. The first thing is called the major axis. So the major axis, pick my color here, is the longer axis of symmetry. So you're going to have 2 on an ellipse. So this is going to be the distance between the vertices. Okay, so if you look at the picture off to the left there is a longer line, so vertex to vertex, that is the major axis. Okay, as opposed to the minor axis, that is the shorter axis of symmetry. Okay, that is going to be between something called the co-vertices. So that's kind of a new term that I'll talk about in a second. So here's a co-vertex and a co-vertex. So that shorter length, that is the minor axis. So major, big, minor, small. Center is kind of just like in a circle. Center is h comma k. I'll go over the equations in a moment. And then we just talked about the vertices and co-vertices. So vertices are the endpoints of the major axis, so the longer one, and the co-vertices are the endpoints of the minor axis. Okay, so just like with parabolas, you can have a horizontal ellipse or you could have a vertical ellipse. So we're going to go over a couple things right now with those. So first thing, the vertices. So again, that's always on the endpoints of the longer axis. So the vertices are always plus minus a units away from the center. So on the horizontal one, like this would be a vertex, and this would be a vertex. Okay, so from the center, like this distance right here, that would be A. And it would be the same thing on the other side, that would be A. On a vertical ellipse, same thing. So the vertices are the longer axis. So here's a vertex, here's a vertex. So it's the same, this distance A from the center to a vertex. So plus minus A, up or down, left or right. So then similar thing with the co-vertices, those are plus or minus B units away from the center, so the shorter axis. So like this would be a co-vertex, so this right here would be B. Okay, that's also a co-vertex. Same thing on the vertical, the shorter axis from the center, that would be B units away. That's a co-vertex, here's a co-vertex. Okay, so like if I'm looking at this horizontal one, like I said right here, this is A units. The length of the major axis is just 2 of those, right? From the center out, it's A. So the length of the major axis is 2A. The length of the minor axis just would be 2B because it's 2 of them. The foci are plus or minus C units from the center. So those are like this distance right here. That's the focus, that's one of them. That would be C units away. Same thing over here, like this distance right here would be c units away. We'll talk about that in a little bit. Okay, so those are kind of just some new vocabulary terms. Let's go over the equations next. So the formulas are very similar to each other, just kind of like in a parabola. So a horizontal ellipse would look like this. You'd have x minus h squared over a squared plus y minus k squared over b squared. And then ellipses are always going to equal 1. So let's look at the difference between that one and what a vertical ellipse looks like. So vertical, you still start x minus h squared, but now x would be over b squared. It's always plus in between. Then this would be y minus k squared over a squared equals, again, always 1. Okay, so just something to note is just where the a and the b are located. So just off to the side here, I'm going to jot down a is always greater than b, okay? So basically, whatever bottom number is bigger, like if it's under the x, you know it's going to be horizontal, and if the bigger bottom number is under the y, it's going to be vertical, okay? There is no c in the equations, but sometimes we're going to have to find the foci. To find that, the formula to find c, kind of like the Pythagorean theorem, but not. It's c squared equals a squared minus b squared. So you just subtract two numbers. Okay, so now that we have the equations, let's graph a couple here. So let's look at number 1. And you have some steps there too. So first step, write the equation in standard form. So number 1, this is in standard form, so that's good. Okay, it looks just like the equation. First, I can graph the center. Okay, now notice that you would have like h and k. This one doesn't even have any parentheses, so that means my center is at 0, 0. Right, it's like x minus 0 squared and y minus 0 squared. All right, then I would say next thing is figure out if you have a horizontal or vertical ellipse. So remember, the A is always bigger than B, so it just depends on where A is. So since 64 is bigger than 25, the bigger number is under x squared, so that means A is under x squared, so that means that you have a horizontal ellipse on this one. So it's going to be wider than it is taller, okay? So what I would do off to the side then, once you know that this is the bigger one, you know that that's a squared. So a squared is 64, which means a is the square root of that, which is 8. And then that means b squared is the other denominator, which is 25, which means b is 5, right? The square root. Okay, so the a value always tells you where the vertices are. So that's the distance from the center out. So since you know this is horizontal, for my vertices, I'm going to count left and right. So I'm going to go from my center, right 8, and left 8. Okay, those are my vertices. So over here I would have 8, 0 and negative 8, 0. Those are the 2 points I just plotted. Then the co-vertices, so vertices, this was the A, co-vertices comes from the B. That is 5 units. So from the center, I'm going to go up 5 and down 5. So like here and here. Okay, so those are the points 0, 5 and 0, negative 5. Okay, and then you pretty much have your ellipse already. The last thing, and you could even draw it right now. These are like not super easy to draw, but I think the iPad helps us, sort of. It's a little twisted, but that one doesn't look so great, but that's it, okay? Now the foci, these are really good for like application questions, which we're not quite at yet, but they are gonna be good to know. So we said the foci, use the formula c squared equals a squared minus b squared to find and graph the foci. So I have a squared and b squared right here. So c squared is going to be 64 minus 25, which is 39. So if I want the c, I get the square root of 39. Okay, now since you're square rooting, it's actually plus or minus the square root of 39, and that's really it. Now again, that is the distance. It's always going to be on your major axis. okay, plus minus C units from the center. So when I go back up here, I'm just kind of thinking like roughly the square root of 39, that's just a little bit bigger than 6 something, right? Because that would be like 36. So just as far as putting that in my picture, 2, 3, 4, 5, 6, that would be kind of like here and about right here. Those are your foci. It doesn't really have anything to do with actually making the graph. But like I said, those are kind of application questions that we might get to later if we have time. So as far as writing those points, that would be like plus minus square root of 39 comma 0, right? You went right root 39 and left root 39. And that's your first ellipse. Okay? Let's do one more, just so you can see a different one. Let's go to number 2. Okay, so right away decide if this is vertical or horizontal. Look at your denominators. Since the bigger number is under y squared, this is a vertical ellipse. So it's going to go up and down kind of like that. Okay, so your center, just like in a circle, this would be at 5, -2. It's the opposites of whatever's by the x and the y. So 5, -2. It's right there. Okay, now your vertices, remember, jot down your a squared and b squared. So a squared, remember, it's not always the first denominator, it's the bigger one. So this one is a squared here. Okay, so a squared is 36, which means a is 6. B squared is 9, so b is 3. Okay, since I know this one's vertical, that means my a value, that helps me with my major axis, that's going to go up and down, not left and right. So from my center, not the origin, from my center I'll go up 6 and down 6. Okay, and then my minor axis from my center, I'm going to go right 3 and left 3. Okay, and then you pretty much have your ellipse. Oh, that wasn't too bad. But let's jot down our points. So the vertices, that was the longer axis, so that's the point 1, 2, 3, 4, 5, 4, and 5, -8, right? Just counting where those points were. I guess I probably should have put that in navy blue. All right, and then the co-vertices, that was the smaller axis, so those should be the points. First one's at 2, -2, and 8, -2. Okay, and then your foci, that's always c squared equals a squared minus b squared. So 36 minus 9, which is 27, square root both sides. So you got plus minus the square root of 27. So again, just kind of estimating that 5 squared is 25, so this is just a little bit bigger than 5, right? Now you do have to be careful on this one because it's from your center. So where your point is, it's going to be like 5, and then you're taking that -2, and you're going to add or subtract that square root of 27 from it. Because we're on our major axis, right? So we're either going up or down that. 1, 2, 3, 4, 5. So it'd be like kind of really close to your vertices. And that's how you would write that. You could write them separately if you wanted, but that would be it. Okay? You can try some of these others if you want, but I just wanted to make sure we did one vertical and one horizontal, and then we'll talk more about these tomorrow and get into some writing equations. All right, thanks guys. Email me if you need anything. Bye.